All right, so I just want to go through the last example that we didn't quite get to in class and maybe talk a little bit about the motion and how we can use this with the applications of derivatives. All right, so let's go ahead and start with this one. Letter A asks us to find expressions for the particle's velocity and acceleration. Now, so what we're going to do is we already know that velocity is the derivative of the position or displacement equation. So we're going to take that first equation, which was s of t, which was equal t to the third minus 3t plus 1. And we're going to take the derivative, which will give us s prime, which is the same thing as the velocity, which will be 3t squared minus 3. It also asks us for the acceleration. The acceleration is the second derivative of the displacement, or the derivative of the velocity, which then is, of course, acceleration. So in this case, we'll take the derivative, which will be 6t. The constant is gone. So we now have, that minus should not be there. That prime should not be there. So anyway, there we go. We've got essentially our three equations. Check. Letter B, find the initial conditions and hence describe the motion at this instant. And so in order to do this, we noticed in class as we were trying to figure things out, we need all three pieces of information if we're going to appropriately describe what's happening here. So I'm going to put 0 in for t, and when I put 0 in for t, first I'm going to do s of 0, and I find when I do that I'm going to have 0 cubed minus 0 plus 1. So that means at the initial point in time, I'm at x equals 1, okay, 1 centimeter from the origin. All right, then I'm going to do s prime of 0, or the velocity. So when I put that 0 in, I'm going to get negative 3, which means I'm moving 3 centimeters per second to the left. Okay, so I'm 1 centimeter to the right. I'm moving at a rate of 3 centimeters per second to the left. And then if I look at the second derivative and put 0 in for that, I find that at this point there is no acceleration. And so therefore, all I know is that I'm 1 centimeter to the right, and I am moving at 3 centimeters per second to the left, not speeding up or slowing down at this instant. All right, so check number 2. On to letter C. Describe the motion of the particle at t equals 2 seconds. So now I'm going to do the same thing. I'm going to go ahead and put in 2. So that will be 2 to the third, which is 8, minus 3 times 2, which is 6. So 8 minus 6 is 2, plus 1 is 3. All right, then I'm going to do s prime of 2, which is, of course, the velocity. And so if I put 2 in, that'll be 2 squared, which is 4, times 3 is 12, minus 3 is 9. So I'm just plugging these into the calculator and then the equation. And of course, acceleration is the second derivative. And so I'll plug that in. 6 times 2 is 12. So what this tells me is that I am 3 spaces to the right. So I'm over here. I am traveling at 9 centimeters per second to the right because it's positive. And my acceleration is 12, which means I am speeding up. And I know that because I have a positive acceleration and a positive velocity. So the acceleration is going to make me go more and more positive. And so speeding up. All right, letter D. Find the position of the particle when the changes in direction occur. Okay, now we talked about in class, we talked about these key words. Now a change in direction, at that change of direction, whether it's going up and coming down or whether it's going right and coming back to the left, at that point in time, we need the velocity to be 0. And so what we're going to do is we're going to take this idea of velocity being 0, and we're going to plug it in. So for the velocity equation, I'm going to go 0 equals, and the velocity equation is 3t squared minus 3. Now, I already know that somewhere between t0 and t2, I changed direction. So one of my answers had better be between t0 and t2, but the other one can be somewhere else. So let's go ahead and solve. So 0 equals, and we can, looks like we can factor out that t. So we'll go t squared minus 1. and then we can go 3 times t plus 1 and t minus 1, and so therefore t equals 1 and t equals negative 1. So those are the 2 points in time when I change direction. One of them is at 1 second, which then I changed going to the right. The other one was before that at time negative 1. Okay? Now, of course, here it actually says that my domain is t is greater than or equal to 0, which means we get rid of this one, so it's only that one change in direction. All right? Now, draw a motion diagram. We're actually not going to worry about that. If you see that, then you can just skip over it in your homework. But the idea of a motion diagram is it just shows your position and the direction of your motion. Okay, so if I were to draw a motion diagram, I've got a couple of points of information already. At time 0, I was 1 centimeter to the right. So here's my position of 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth in the negative direction. So 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So at time 0, I was right here, 1 centimeter to the right, and I was moving to the left. Okay, so that was at t equals 0. At t equals 1, if I were to put 1 in here, 1 cubed would be 1, minus 3 would be 1 minus 3 is negative 2, plus 1 is negative 1. So at t equals 1, I would be here. And remember, at 1, I'm changing direction, which means that I'm not moving at that point. And so then I would have t equals 2, and at t equals 2, we already said we were at 3. So t equals 3. I'm here and moving to the right rather rapidly at 9 meters per second. And you'll notice that this arrow is longer than that one because I'm moving faster here than I was there. Remember, velocity is a vector, so it has magnitude and direction. Okay, that's a pretty rough sketch of the motion diagram, but really you don't need anything more than that. Okay, if you wanted to kind of connect all these things, you can, but really this is the best way to show it, showing that you have a less speed, more speed, showing the direction, all that is available there. Okay, letter F, for what time intervals is the particle's speed increasing? Well, if the speed is increasing, that means that the acceleration and the velocity are in the same direction. All right? Now, we already know that we're starting at t is greater than 0. And it looks like I was going to the left here with a right acceleration. You'll notice that for any value of t greater than 0, the acceleration will always be greater than 0, greater than or equal to, because I guess it could be 0 at that initial instant. And so the acceleration is always 0. That means I will only be speeding up when my velocity is in the positive direction. And so therefore, you could figure this out in any number of ways, but the easiest way is, since we already know the acceleration has to be positive, we're looking for the velocity to be positive. You can actually figure it out from your drawing, but if you say v of t needs to be greater than 0, then you can just go 3t squared minus 3 is greater than 0, and then you can solve 3 times t minus 1, t squared minus 1 is greater than 0. And so then if we look at the sign diagram at 1 and negative 1, if I plug 0 in, at 0 I have a negative, which means I have a positive speed when t is greater than 1. And so this right here will help us to answer F. Now I went through that pretty quickly, and the reason is because we already knew that here we were moving to the left, and at t equals 1 I was changing direction, which means that anytime after t equals 1 I'm moving to the right. And since I'm moving to the right there, that means I will always have a positive acceleration, positive velocity, therefore I'm speeding up, I'm increasing for all of that F. Okay, what is the total distance traveled in the time from 0 to 2 seconds? In order to get that, there's a number of ways that you can do that, but the best way, obviously, at t equals 0, we start at 1, we travel down to the negative 1, which is a distance of 2, and then as we go from 1 to 2, I'm going to have to figure out where I was at t equals 2. So, we already did that. Sorry, this was t equals 2. I miswrote that earlier. So at t equals 2, I was at 3. And so I go 2 spaces that way, and then I go 1, 2, 3, 4. Yeah, 4 in that direction. So 2 plus 4 is 6 centimeters. And so you can tell just by counting up the spaces. 1, 2, 3, 4, 5, 6 spaces to get from the 1 to the -1 and then back to the 3. Okay, so that's basically the idea. I hope that's helpful as you go through your homework. Pay attention to the keywords and to the things that it's asking for. Remember to pay attention to all three: the displacement, the velocity, and the acceleration. All right, so hope that was helpful, and see you next time.